Friends, today I am now going to discuss a simple harmonic oscillator problem in quantum mechanics that was based on first order perturbation theory. So let's discuss the problem. This problem has come in the exam of CSIR NET also. So from this problem you will be cleared about first order some basics concepts of first order perturbation theory. So let's discuss the problem. So what was given in the problem? A Hamiltonian was given, that was p square by 2m plus half m omega square x square, that is kinetic energy term and potential energy term, you all know, plus a perturbation term was there. What was that perturbation term? Perturbed term was that h cut by root 512 exponential of minus m omega x square by h cut. This was given in the questions. Now it was asked, so it is a perturbed Hamiltonian, and now it was asked that what will be the energy, ground state energy to the first order perturbation correction. So let's discuss how to proceed, how to do this problem. So first concept you have to know, in the first order perturbation theory, if you have to do first order correction on energy, what you will do? Suppose you have to do first order perturbation in energy, you have to do just expectation value of the perturbed Hamiltonian. H prime is actually denoting perturbed Hamiltonian. Just if you take expectation of, this symbol is meaning to the expectation value. Expectation value means, suppose you have been given a perturbed Hamiltonian, that is H prime, and you are taking expectation of that. So how will you write that? If the wave function is normalized and you are taking first order correction in the ground state, and psi 0 be the ground state wave function, so psi 0 H prime psi 0 divided by psi 0. This is bracket notation we in general used in the Dirac's bracket theory. So if the psi 0 is normalized eigenfunction or wave function, then that will give you 1. So in that case, here also the perturbed wave function is given. The perturbed wave function is what? Perturbed Hamiltonian is given. Total Hamiltonian is what? Kinetic energy term p square by 2m plus half m omega square x square, let us denote it by h0, plus perturbed Hamiltonian term h cut omega by root 512 exponential of minus m omega x square divided by h cut. Let us consider this as h prime. So this was the total Hamiltonian with unperturbed Hamiltonian and perturbed Hamiltonian. So to obtain first order correction in energy, what you will do? You will do h prime, and it was asked in the ground state, where you have to take the first order correction in the ground state. So for quantum harmonic oscillator, first of all you have to know the ground state wave function. Ground state wave function for quantum harmonic oscillator, what will be that? M omega by pi h cut whole to the power 1 by 4. Let me write properly. So what will be the ground state wave function of the quantum harmonic oscillator? Psi 0, that is the ground state. 0 means ground state. I am actually denoting 0 means here ground state wave function. Ground state wave function of quantum harmonic oscillator, psi 0 will be m omega by pi h cut whole to the power 1 by 4 exponential of minus m omega x square divided by 2h cut. This is the ground state wave function of quantum harmonic oscillator, and you have to do what? you have to do the first order correction energy, that means for expectation value of H prime in the ground state. Ground state means what? You have to take the ground state wave function, and this is normalized wave function. Normalized wave function means what? Normalized wave function means actually psi 0, brash psi 0 and ket psi 0. Their inner product or scalar product, you can tell whatever, that will give us 1. Now we will do what? We will do the expectation value of H prime expectation value, that is psi 0 H prime psi 0. So how can we write this? Actually we can write this integration of minus infinity to plus infinity psi 0 star H prime psi 0 d3x, or you can write simply dx. Okay, so let's calculate this. So psi 0 star and psi 0. Psi 0 star means what? Complex conjugate of the wave function psi 0. So complex conjugate means what? If you take complex conjugate of I, means iota, imaginary number, that will give us minus I. That's actually complex conjugate. But here the wave function is real. Real means no iota term, no imaginary term is given in the wave function. So psi 0 will give us the same result as psi. That's what? Let me write. That is m omega by pi h cut whole to the power 1 by 4 exponential of minus m omega x square divided by 2h cut. Same result, that is psi 0 star equals psi 0, and h prime is there in the integration. So if I write the integration properly, so m omega by pi h cut, first I am writing psi 0 star whole to the power 1 by 4 exponential of minus m omega square divided by 2h cut into, now I am writing in the inside the integration the multiplication term, h cut omega divided by 512 exponential of minus m omega x square by h cut into psi 0. Psi 0 is what? M omega by pi h cut divided by whole to the power 4 exponential of minus m omega x square to 2h cut into dx. This big integration we have to do. So first you can simplify within a second by just looking the constant term. See here, both wave functions are same. So this is constant term. Constant term is what? M omega by pi h cut whole to the power 1 by 4. And here exponential minus m omega x square into by 2h cut, and here also exponential of minus m omega x square by 2h cut. What will give? What will this give? This will give m omega by pi h cut whole to the power 1 by 4 whole square. That will give us, that will give half, and exponential minus m omega x square divided by 2h cut whole square means exponential of minus of m omega square h cut into h prime. H prime was what? That h cut omega by root 512 exponential minus m omega x square divided by h cut. Now I am simplifying the integration. Keeping the constant term outside. What is a constant term? Constant term is m omega divided by pi h cut whole to the power half into h cut omega divided by 512. Okay, and inside the integration minus infinity to plus infinity, 1 exponential minus m omega x square by 2h cut whole square, that will give you what? Exponential minus m omega x square to 2 exponential minus m omega x square into h cut into the exponential part of Hamiltonian, that was with the h cut omega root over 512, another exponential term, that is exponential minus m omega x square divided by h cut dx. So when you will multiply both the term, what these will give? These will give us, let's write the constant at C1 for our convenience. I'm writing this constant as C1 for our convenience. These will give us exponential minus m omega x square divided 2m omega x square divided by h cut into dx. Now what the thing you can do for simplification of the problem, one property of indefinite integration, that is, see here, x square is here. X square is what? X square is even function. Even function means what? Even function means you can change the integration limit by how? You can change the integration limit in such a way that it will be 0 to infinity multiplication with the term 2 into 0 to infinity. So what we are getting, that constant term is what? Constant term C1 or C whatever is m omega by pi h cut whole to the power 1 by 4, sorry 1 by 2 whole to 1 by 4 whole square, both will give 1 by 2 into h cut omega by root 512. We will calculate it separately, okay? And the integration and into the 2 was there also, because we have changed the integration limit. So take it as another constant term C, and the integration is I equals integration 0 to infinity. I equals integration 0 to infinity. What was that? Exponential of minus 2m omega x square divided by h cut dx. Now here you have to know a formula of integration. What is the formula of integration? A general formula is that integration 0 to infinity x to the power m e to the power minus alpha x to the power n dx. If such thing is given, what is that thing is given? E to the power 0 to infinity x to the power m into exponential of minus alpha x to the power n, then the result is 1 by n gamma function m plus 1 divided by n divided by alpha to the power m plus n by n. This is the property. So I'm writing the result properly. Integration 0 to infinity x to the power m, integration 0 to infinity x to the power m e to the power minus alpha x to the power n dx, that will give us 1 by n gamma m plus 1 by n divided by alpha to the power m plus 1 by n. So from that integration, what we conclude with the e to the power minus m omega x square by 2h cut relation 0 to infinity e to the power minus 2m omega x square by h cut, you can conclude that m value is 0 because no x term is there, no x term, x to the power 0. We can write x to the power 0 means what? X to the power 0 means 1. So just ignore it. So m value is 0. Alpha is what? Here alpha is 2m omega divided by h cut. N value is what? E to the minus alpha x square. So n equals 2. M value 0, m value 0, n value 2, alpha equals 2m omega by h cut. So just apply that formula. That's it. So just applying this formula, erase it first, because here I have to write that big integration. I am calculating the integration differently, then I will multiply it with the constant term c that I have to calculate separately. So 1 by here m n value is 2, so 1 by 2 gamma m value is 0, 0 plus m plus 1 by n, so 0 plus 1 by 2 divided by alpha to the power, alpha means what? Alpha means 2m omega by h cut whole to the power 0 plus 1 by 2. So here one thing you have to know of gamma function. Gamma half that has value always root pi. Gamma half has value always root pi. So what we are getting here? We are getting half into root pi into root 2m omega by h cut. So what we can write here? Can write half into h cut pi divided by 2m omega. Writing properly, divided by 2m omega. Now writing that constant term. So here first I equals what we have got. Here I equals we got, writing it properly, half into root h cut pi divided by 2m omega we have got. So now writing that constant term was what? M omega by pi h cut whole to the power 1 by 2 into another term was there. So what was that another term? Another term is 2 into root h cut omega, sorry, not in the root, that was given h cut omega divided by root 512. So this was the constant term. So it's big calculation. So h cut omega into root 512. Root 512 means now what we have to do? Just write the integration I into C1. That means what you have got? You have got at 1 by 2 into h cut pi divided by 2m omega into m omega by pi h cut root, okay, into 2 into h cut omega divided by 512. Okay, so I'm writing properly the total integration value. Total integration value is, we are getting that half into, after multiplicating the constant term and integration term, half into h cut pi 2m omega, their total root, into m omega pi h cut whole to the power half into h cut omega 512. So here, see here, root m omega and here root m omega, they will cut, they will be cancelled out. Root pi h cut, they will be cancelled out. Here half and here 2, they will be cancelled out. So what we will get? We will get a 2 will be there, 1 by root 2, because here m omega was cancelled out, into was cancelled out, and here h cut omega by 512. So here what we will get? H cut omega by 1024. So we will write h cut omega by 32. So this is the what term? This is the perturbed term. This is the corrected energy, first order corrected energy in the ground state. And now what you have to write? Total energy. So energy for without perturbation, unperturbed state. What is the energy for quantum harmonic oscillator? N plus half h cut omega. And for ground state, unperturbed state, it is n equals 0. You will get half h cut omega. And half h cut omega with half h cut omega. What is that perturbed energy? Perturbed energy term, that is E01, means first order correction you have got h cut omega by 32. So what will be the total energy? Total energy will be half h cut omega plus h cut omega by 32. So 32 a common, 16 plus 1, h cut omega. That will give us 17/32 h cut omega. So this is the total energy after perturbation and after the first order correction. So that's it for today. This problem has come at CSIR NET 2022, and from this problem you will get so many new concepts of quantum harmonic oscillator and so many new concepts of integration. That's it for today. Thank you so much for patiently watching.